All right, hello guys. Today we'll have a very interesting question here before us. This is an Olympiad question from Germany. So the question here we are seeing is 2 to the x power is equal to x raised to power 32. Now the aim of solving this is to show that the left hand side is equal to the right hand side by finding the value of x. Of course, we will need to obtain the value of x to be able to test that the right hand side is equal to the right hand side. All right, let's go. So the first thing we are going to be doing here, of course, is to try to separate the powers of numbers to be one side and the powers of the unknown to be the other side with the unknown. So now the first thing we're going to be doing is we want to clear our 2 here. We want to clear the power of 2, that is x, so that 2 will be alone. Now what we're going to be doing is that all right, we'll have to multiply both powers by x inverse. So this is going to be what? 2 to the x power multiplied by what? X inverse. Now this is the same thing as x to the 32nd power multiplied by what? X inverse. Of course, you know that if you have a inverse multiplied by a, this is the same thing as what? A all over a, and that's going to give you 1. So we'll have here to be 2 raised to power 1 is equal to what? X raised to power 32. X raised to power 32 multiplied by what? X inverse. So we want to do away with this 32 as the power of x. So what we're going to do here is to multiply the power of both sides by what? 32 inverse. So that we're going to be having 2 raised to power 32 inverse here, and this is equal to what? X raised to power 32 inverse multiplied by what? 32 multiplied by what? X inverse. So that this whole thing here is done away with. Now we're going to be having what? 2 raised to power 32 inverse is equal to what? X raised to power x inverse. If you have something like a to the inverse of 1, negative inverse of 1 is something as 1 over a. So definitely x inverse here is something as 1 over x, and what? 32 inverse is something as what? 1 over 32. Now let's impute this here. We'll have what? 2 raised to power 1 all over 32. This is equal to what? X raised to power x 1 all over x. Now if you look at our right hand side very well, what do you observe? We observe that there is an x here, and what? We have x as a base, and the denominator of the fractional power of x is also what? X. So we have to make the left hand side look like that by making the base to be the same thing as what? The denominator of what? The fractional power of the base here. So supposing we have 32 up here and 32 down here, then this will be done with. But we don't have 32 down here, so we are going to force this 2 to become a 32. Now having 1 all over 32 is the same thing as what? 2 all over what? 64. Of course, we'll not change anything, because when you reduce it, you reduce it by 2, everything comes back to 1 over 32. Now that means, or that simply means, 2 to the power of 1 over 32 is going to be the same thing as what? 2 to the power of what? 2 all over what? 64. We haven't really changed anything here, have we? So the right hand side is going to remain x to the power of 1 all over x. Not change anything here, because when you reduce this fractional power here, you come back to 1 over 32. Now of course we can just decide to take this 2 inside to have what? 2 squared all over what? 1 all over 64 is equal to x raised to power 1 all over x. We've not done anything wrong here, because of course remember the law of indices that says a to the power of m multiplied by what? N is the same thing as what? A to the power of m n. So if you apply this law here, you come back to what? 2 raised to the power of 2 over 64, which isn't really a big deal. So now let us proceed. We are going to proceed in this manner until we make sure that both the base and the denominator of the base's power is the same thing. Now this is the same thing as 4 raised to the power of 1 all over 64 equal to x power 1 all over 1 x. This 4 here has increased from 2, but this isn't really the same thing as 64, is it? So we continue. Remember, 64 is the same thing as what? 2 all over 128. If you reduce 2 all over 128, you arrive at 1 over 64. 1 all over 64 is the same thing as 2 all over 128. So we just pick this and plug it in here. Of course, we haven't really changed anything, have we? So this is going to be what? 4 raised to the power of 2 all over 128. This is equal to what? x raised to the power of 1 all over what? X. Now, like we did the other time, this is going to be the same thing as 4 squared to the power of 1 all over what? 128. And this is equal to x to the power of 1 over x. Now, 4 squared is what? 16 to the power of 1 all over 128. And this is the same thing as x to the power of 1 all over x. But 16 is not the same thing as 128, is it? So we proceed. Remember, 121 all over 128 is the same thing as what? It's the same thing as 2 all over what? 256. So that when you reduce this, it comes back to this. So we haven't really changed anything logically, or let me say mathematically, you understand? So the next thing we have to do is we'll plug this in this stead. So we're going to have 16 to the power of 2 all over 256 is equal to what? X to the power of 1 all over x. Now, just like we did earlier, this is going to be the same thing as what? 16 squared into what? 1 all over 256. And this is the same thing as what? X to the power of 1 all over x. But if you square 16, what are you going to have? Of course, we'll have 256 to the power of what? 1 all over 256. This is equal to what? X to the power of 1 all over x. Very good. Now, what did you observe? We have an x here as a base, and we'll have an x here as what? The denominator of what? The fractional power of x. Same thing we'll have on our left hand side. We'll have 256 here as the base, and we'll have what? 256 as the base of the fractional power of 256. So basically, if this 256 is equal to this x, that means x is equal to what? 256. All right, and this x is the same thing as what? 256. 1 is 1. So our x here is what? We have arrived at x is equal to 256. Now let us prove that this is really equal to 256. The original equation here is what? 2 to the x power is equal to 8 to the 32 power, x to the 32 power. Now let's plug in our value here, which is 2 to the power of 256 is equal to what? 256 to the power of what? 32. So if you punch your calculator very well, your left hand side is going to be this long number I have given here, and if you try it with your right hand side, it's going to give you the same number.